Today, lesson 25B, we return to the idea of using proportions to solve word problems. We're going to go a little more in depth today. So we're going to use proportions to solve word problems, explaining words, the given rates, and some other things involved in that, and then our usual why am I learning this? All right, so the idea of setting up these things, the proportions that we would want to use from word problems is identical to what we did earlier, except the difference is many of these don't come out even, and so what we want to do is we want to do some checking to make sure that our answers make sense. So number one, it says a loading crew estimates that it can load 6 boxes every 5 minutes. At that rate, how many boxes can they load in 28 minutes? What I would like you to do right now is I would like you to write down the proportion that you think you could use to solve that. And then we'll talk about some things that are involved within this problem. So I'll give you about 30 seconds. In this problem, if you're given a rate, or this is any word problem, if you are given a rate and you are asked to find another rate, that's when you can use a proportion to solve a problem. And we are given a rate right there. 6 boxes every 5 minutes, that's a rate. And as I walked around, that's what most of you use for your first fraction. That's a rate, 6 boxes every 5 minutes. Now I put the labeling in there only to make sure that when we set this thing up, we have, in my case, boxes on top of both of my ratios and minutes on the bottom. But we could also do minutes on top and boxes on the bottom. It doesn't matter, but most of you went with 6 over 5. And then it says, at that rate, how many boxes can they load in 28 minutes? So we're given a rate, and we're asked to find another rate. And so what most of you did is you went with 6 over 5 equals x over 28. But that's not the only proportion that you could use to solve this thing. Here's what most of you did. But look, you could also use this proportion. And if you did that, that means you have minutes on the top and boxes on the bottom. Or we could start with the x over 20 and have equal 6 over 5, or the flip of that. Any of those as a start would be okay. Most of you used the first one. Here are some incorrect proportions. And there are many reasons why each of these don't work, and most of them is because we don't have both boxes on top or both boxes on the bottom, and so on. So we need to make sure that when we set up our proportion, we set it up correctly. But I'm going to go with the first one because that's what most of you ended up using. All right, I would like all of you to solve that proportion. All right, so we're going to go with that proportion right there. Now, there are a number of ways of dealing with this. One way we talked about, and I'm sure that this is, many of you recognize that we can't multiply 5 by a whole number to get to 28. The first way that we dealt with this is we decided, well, we could multiply by something, and that would be 28 over 5, because 5 times 28 over 5 is 28. We could do it that way. Most of us don't really want to do it that way because it looks like it's a little more complicated. So I could get to what I need by multiplying top and bottom by 28 over 5. So I'm going to take that off of there because that's not the way most of us are attempting to do it. The way most of us are attempting to do it is thinking about this in terms of just like a regular equation. So we would multiply both sides by 28. I don't know why I just wrote that 1 right there. And so when we do that, these cancel out, and on the left-hand side, or excuse me, on the right-hand side, I am left with x. Now I need to figure out what that is right there. One thing I saw some of you do is, for some reason, some of you multiplied 28 by 6 in your head. I don't recommend you doing that unless you're very sure of yourself. I can't do any cross-reducing, so I'm going to go ahead and multiply 28 times 6. That's 48. 6 times 2 is 12, plus the 4 is 16, so that's 168. So right now we have 168 over 5. But now I need to figure out what 168 over 5 is. So I'm going to stop for a second. And if you didn't get 168 over 5 for that part, I want you to erase what you have and now fix it and finish it off. All right, so when we figure out 168 over 5, or 168 divided by 5, we end up with 33 and a remainder of 3. So that's 33 and 3/5 boxes. But what I want to talk about right now is, does that make sense for what we're doing? So let's take a look at this. Does this answer make sense? So if we scale up with equivalent fractions, we can sort of figure out whether that makes some sort of sense for what we're doing here. So the given rate that we were given was 6 boxes every 5 minutes. So if I take that given rate and scale it up, multiplying top and bottom by 2, and then taking 6 over 5 and multiplying top and bottom by 3, and I keep writing equivalent ratios until I get past where I need to be, this is where I can stop. Because look, the bottom numbers represent minutes and the top numbers represent boxes. So right here, 28 minutes is somewhere in between those two numbers right there. And this is where you should be maybe jotting some of this down a little bit so it kind of makes sense to you. 28 minutes is somewhere in between 25 and 30. So my next question is this. Is 33 and 3/5 in between those two numbers right there? Yes or no? Yeah. Yes or no? Yes, 33 and 3/5 is in between 30 and 35. So what that means is that this makes sense for what we're doing. And we should always mentally make sure that what we get makes sense. So in 28 minutes, they can load 33 and 3/5 boxes. So in order to use a proportion, we have to have a rate, and we have to be finding a rate. So inside of the box in your notes, you have some things you need to fill in here. Words or statements that are commonly found in rate problems. For every, for each is another common one. Per is another common one. We've seen all of these things in other types of word problems that we've done also. So in this number 1 that we just did, 6 boxes every 5 minutes, that's the same thing as 4 every 5 minutes. So that's a key word that tells us we are given a rate, and then we're trying to find a rate. So that means, or that tells us, that using a proportion is okay. All right, and that's the thing we have to make sure of. 6 boxes for every 5 minutes, that fits what we're trying to do. 6 boxes per 5 minutes. That's different ways of phrasing it. All right, everybody try number 2. Let's do this. Let's start with the setup first. In this problem, we are given a rate and we're asked to find another rate. And the given rate is 6 cups of flour to make 54 cookies. That's the given rate. So that means, since we're also trying to find another rate, we can use a proportion. Daniel, what proportion would you use to solve this?
6 over 54 equal to 10 over x.
Very good. And so doing the setup that you did, you have cups of flour on top and cookies on the bottom, so we need to make sure that we stick with that. We have 10 cups of flour, so it needs to go on top, and a variable will go on the bottom. Now, this is where we have to use the upside down proportion property to make sure that we can solve this using the equation method. So let's use that upside down. Let me erase that. So that means we're going to flip both ratios. The upside down proportion property. That means the same thing as the original proportion that we had written down there. Solve it from there, please. All right, so one of the things that I haven't mentioned a lot of yet, but this is the problem where I feel like I should, and that's this. If you can reduce the given fraction, and I know I've mentioned it a little bit, just not a lot. If you can reduce the given rate or the given fraction or the given ratio, however you want to think about that, you should, because it will make the mathematics within your problem a lot easier. Can you reduce 54 over 6? Yeah. And so if you did that, it would make the numbers a lot smaller. But I'm going to pretend like you didn't even notice that. And when I walked around and looked, most of you did not. So what we need to do is we need to multiply both sides by 10. That's the reason why we needed the variable to be on top, so we could just solve it like a regular equation. And so we end up with x equals, and we end up with 540 over 6, or you could try and do some cross-reducing right here first. Lots of things that you could do, but regardless, you should end up with x equals 90. So what that means is that we can make 90 cookies with 10 cups of flour. If we're given a rate and we're asked to find another rate, we can solve using a proportion. All right. And now I'm going to double check to make sure that this answer makes sense. The given rate that we had was 6 cups of flour for every 54 cookies. If I scale up, we can see 10 cups of flour is in between 6 and 12, and 90 cookies is in between 54 and 108. That means that the answer makes sense. Okay. Everybody try number 3. All right, when I walked around, most of you set it up the same way. We are given a rate, 91 books in 7 hours. That is a rate, and we're asked to find another rate. How many books can it print in 12 hours? All right, so our setup, and this is the setup that most of you use, 91 over 7 equals x over, or any variable, over 12. You can reduce 91 over 7, by the way. That would be 13 over 1, and if you did that, that would be the unit rate. But most of you did not see that. So at this point, we would need to multiply both sides by 12, and most of you are making that 12 over 1. It doesn't matter. But regardless of that, at that point, we end up with 1,092 over 7, which happens to be 156. So in 12 hours, a printer can print 156 books at that same rate. All right, everybody try. Number 4. So here we go for number 4. We are given a rate, 20 rolls for every, 5 tablespoons of butter for every 20 rolls. That is the given rate. That helps us with our setup, because then we are asked to find another rate. So the question is, how many tablespoons, that's where the variable goes on top, will it take to make 35 rolls? From there, multiply both sides by 35, and that would give us 175 over 20. I know that some of you reduced before you did that. This is what I mean by that. If you multiply both sides by 35, you can do some reducing right here, which is exactly what I would do. So we might end up with 35 over 4 instead, but it doesn't really matter because you're still going to end up with 8 3/4 tablespoons of butter, and that answer does make sense. All right, let's go to number 5. So let's take a look at number 5. Are you given a rate? Yes or no? Yes. Some of you are saying yes, and some of you are saying no. John is 9 and Rhonda is 5. That's a rate? No, a rate would be like 20 rolls for every 5 tablespoons of butter, or 91 books in 7 hours. That's a rate. Or 6 cups of flour to make 54 cookies. That's a rate. Or 6 boxes every 5 minutes. That's a rate. John is 9 and Rhonda is 5. Guess what? That's not a rate. But let's pretend like you went into automatic pilot and you set up a proportion like this one, and you used the upside down property and did all that stuff, and you got x equals 10. So let's think about that. Does that answer make sense? No, it does not. And let me show you why. We already know it shouldn't work because we're not given a rate anyway, but if I sort of figure this out, right now, John is 9, and right now, Rhonda is 5. Well, it says, how old will Rhonda be when John is 18? So if John is 18, that means in 9 years, he will be 18. Well, in 9 years, how old will Rhonda be? 14. That answer of 10 makes absolutely no sense whatsoever. Makes no sense. So we have to think about what we're doing. Just because we see 3 numbers in a word problem doesn't automatically mean that we can use a proportion to solve it. Okay? All right, so whatever you did for number 5, I want you to make some notes to yourself to make number 5 make a little more sense. Once again, you cannot use a proportion to solve number 5 because you're not given a rate. John is 9, Rhonda is 5, that's not a rate. All right, I want everybody to take a look at number 6 and tell me what you think about that one. All right, so number 6. If it takes 3 people 7 hours to paint a fence, how long will it take 6 people to paint a fence of the same size? Usually the way you want to determine this is to see if you are given a rate. But let's pretend like you didn't even pay attention to that. And you set up a proportion and you solved it. And you get x equals 14. I want you to think about this for a second. 3 people, it takes 7 hours to paint a fence. Now there's 6 people going to paint that same fence. Would it take more than 7 hours to paint the fence with more people or less?
Less.
Yeah, so does 14 hours make any sense whatsoever? No. This is why we should be at least double checking to make sure that our answer makes sense. And it does not make sense. So we can't use a proportion to solve this. We'd have to come up with some other mathematical way. Because the more people who help paint the fence, the less time it will take, not more. So we need to double check to make sure that our answer makes sense. Just because you see 3 numbers in a word problem, that does not mean automatically that you can use a proportion to solve it. You have to check to see if you are given a rate or not. All right, we are finished for today. But a quick reminder for word problems, look for the words or statements that are commonly found in rate problems, like for every, for each, per. And make sure you're given a rate and you're asked to find another rate. And make sure that your answer makes sense. All right.